Today's video is going to cover the method of factor by grouping. So factor by grouping, first of all, is a method that we are going to use to factor polynomials with 4 terms. So I do have a quick screenshot of your factoring flowchart, and what we see is that when we're factoring, the number of terms makes a big difference on the methods we use. Maybe we're using this method, which is different than this method, so on and so forth. So on our factoring flowchart, there is a spot that tells us if we have 4 terms, we are going to use factor by grouping. So it's just for 4 terms here. Now here's our first example, and what I want you to note right away is that in the lower left-hand corner here, I have included the directions for how we factor by grouping. So what we notice with factor by grouping is if I look at everything, if I look at the entire polynomial, the first thing that we see in our factor flowchart is to look for a GCF. Now if I look at all of the terms, x to the 3rd power, 3x to the 2nd power, 2x, and 6, there is not one common GCF. What I do notice, though, is that these terms, x to the 3rd and 3x squared, they have a GCF of x squared. And the other group, the other last two, 2x and 6, they have their own GCF of 2. So that's what the first step is representing to us. We wanted to make sure that the terms are grouped into pairs of 2, such that each pair should have its own GCF. So I'm going to work with the pairs individually. I'm going to factor out the GCF from each group. So again, we saw that this blue group here had a GCF of x squared. So if I factor out that GCF of x squared, I could rewrite it as x squared times x plus 3. Now I'm going to go work on the other group, right, which was 2x and 6. They had the GCF of 2. So if I rewrite that, that was a positive 2. I'd be left with x plus 3. So we've done step 1 and 2 already. We've actually looked at the groups to make sure that they have their own GCF, and then we factor the GCFs out of those groups individually. Now what we need to do is we need to look for the common factor with both of these. So what we should know, we see that x to the x plus 3 and x plus 3 is seen twice. These must be the same. It's a good checkpoint along our work here. If they're not the same, then you've done something wrong. Now what that means is I can see that I have a few things, and I'm going to underline them. I have this x plus 2 and this positive 2 are both being multiplied by the same thing. Now that reminds me of the distributive property. So think back for a second. If I saw something like x times 4x plus 6, the way that we'd figure that out is we would distribute. So that x would end up being multiplied by 2 different things. It'd be multiplied by 4x when I distribute it here, and then it'd be multiplied by 6. So what I can see here is that if 2 things, like in the situation down here, 4x and 6, are both being multiplied by this x term, that means that x term was something in front of a group of parentheses. So up here, x plus 3 occurred twice. It was first being multiplied by x squared, and it was also being multiplied by positive 2. So that is our final answer. So again, we could think about the distributive property. This term here would be distributed to that. So I'd have x squared times x plus 3, and it would also at some point get multiplied to that. So this would be our final answer. Let's go see another example right away, just so we can get a little better feeling of this. So example number 2 is we need to factor this. And whenever we're factoring, we should always use our flowchart. So I start at top. Do we see a GCF? Now, there's not a GCF of all 4 of them, so I'd say no to that. But what I do notice is there are 4 terms, 1, 2, 3, and 4. So in my flowchart, I know that I need to use factor by grouping. Now, this problem's a little bit different because problem number 1, or step number 1 in factor by grouping says each pair or group should have their own GCF. Now, if I look at the first 2 terms, which I'm going to highlight here in blue, x squared and y do not have a GCF. If I look at the second terms, x and x plus y, they do happen to have a GCF, but both groups should have a GCF. Now, if both groups don't have a GCF, what I would want you to add to your notes here, this may require you to rewrite or rearrange. If not all the groups have a GCF, I need to rearrange the terms. So what I'm going to do is I'm going to put the x's first. So I'm going to do x squared, and this positive x I'm going to write second, and then I'm going to put anything with a y after that. So I see this positive y, and then I see this positive xy. So after I rearranged it, now what I notice if I look at the first group, x squared and x, they do have a GCF of x. If I look at the second two terms, they also have their own GCF. So I can think of them as two separate groups. What's the GCF of that first group? Well, x. So if I factored out an x, I'd be left with x plus 1. I'm going to go look at the second group. I'm going to say, what is their GCF? Well, their GCF is a y. And notice what I mean by that. That's a positive y. So I'm going to go ahead and put a plus sign there. So if I factored out the y, what would I be left with? I'd be left with 1 plus x. Now, as we said before, these two things need to be the same. Otherwise, we've done something wrong. And in this case, they are the same. It just doesn't look like it. I might need to rewrite, but I know that x plus 1, if I add, I can do that in any order. So x plus 1, I'm just going to rearrange. Instead of 1 plus x, let's call that x plus 1. So that's good news for us. What we do see is that this x plus 1 is common. So that means this one thing, x plus 1, is being multiplied by x and by y. So to indicate that it's being multiplied by both of them, I put them into parentheses. So we can see that common factor goes to one parentheses. And then the numbers that were the GCFs originally, oops, that's kind of hard to see, they make up our other parenthesis. And this would be our final answer. And of course, we can always check that. The way we have to check is using the distributive property. And we know how to use the distributive property. So go ahead and take a moment to check that. So we get x squared plus x times y plus 1x plus y. And that is all the original terms from our original equation. So here's our last example. We need to factor this, and whenever we factor, no matter what it looks like, we should always use our factoring flowchart. So the first thing we're going to look for is to see if everything has a GCF. So if I first just look at the numbers like 3, -12, -5, and 20, they do not share a GCF. And what I can see is that this term here doesn't have any x's in it, so I wouldn't be able to take an x from every term. So there is no GCF that I need to factor out. So I'd ask myself how many terms there are, and I can easily see that there are 4 of them, which means I have to use factor by grouping. So with factor by grouping, we always want to make sure that if we group them into pairs of 2, that those pairs of 2 would have a GCF. Now it works out nicely with this one. The first one does have a GCF, right? 3x cubed and -12x. They have a 3x in common. So if I divided, or in other words, factored out the 3x, I'd be left with x squared minus 4. Now, the thing that's new about the second one, if I look at these last terms, they definitely have a 5 in common. Now, if I pull out a 5, and by 5 I just mean a regular positive 5, so I included the positive there, I would be left in parentheses with -x squared plus 4. And as I've been mentioning before, at this point we want to make sure that these two are the same. And if they're not the same, that means we've done something wrong. So what should we do? Well, what I notice is that they're only off by a sign. This was a positive x squared, this was a negative, this was a -4, and this was a positive 4. So as I've been working with in class, when I see a quadratic, I want to keep that coefficient positive. So instead of pulling out a regular 5, we should have pulled out a -5. So I'm just going to go recopy the first part. But if I pulled out a -5, and I would have divided each of these by a -5, that would have given me x squared minus 4. Now this is better for me because x squared minus 4 and x squared minus 4 are the same, which means that that is my common polynomial. So I'm going to factor that out. So this was being multiplied by x squared minus 4, and so was the -5. So I'm going to take out the x squared minus 4. That would have been distributed back to the 3x, and it would have also been multiplied by that -5. So we've come here. Now the thing that's making this just a little bit different is that we're starting to learn now that we must always factor completely. Now what that means is when I'm done with my first step of factoring, I might need to factor more. So for instance, if I look at 3x minus 5, that's just a linear factor, nothing I can do there. But if I look at x squared minus 4, that one can actually factor further. It's just a trinomial, so if I go back and start at the top here, if I go through each one of these, like if I started with this, there is no GCF, it's not a quadratic, so I can't factor it. But with this one, what I would notice is that it is going to be a difference of squares. My a value is 1, the number of x terms, in other words b, is 0, and my c value is negative 4. So I can think of numbers that would multiply to negative 4 and add to 0. That'd be negative 2 and positive 2. So if any of your factors are able to factor further, you must do that. So on this problem, this is our final answer because, again, x squared minus 4 could factor completely. And that starts to summarize factor by grouping. We will work on the summary in class.